Part 5 of Chapter 1 deals with functions and the introduction to parent functions. Big ideas starting out is relations, domain, and range. So a relation is a pairing of numbers in one set with numbers in another set, basically any set of ordered pairs, where domain is the set of our first coordinates, or the x values, while the range is the set of the second coordinates, or the y values. So our first questions ask us to identify the domain and range, and we're given a series of ordered pairs. So our domain is, again, the x values. So that's going to be 0, 2, 3, and 5. Whereas the range is the y values, which are 1, 4, 7, and 4 is repeated. So we just kind of leave it go. Okay, so we don't duplicate anything. Oops, that was not a good bracket. So our range is composed of 1, 4, and 7. Next, in number 2, for our domain, our x values, we like to put them, as we get a little more particular, in order from smallest to largest. And as we saw in number 1, dealing with the range, we do not duplicate anything. So for our domain, our x values, we've got -1, -3, 6, and -1 is repeated. So -3 is our smallest number for x. So we've got -3, then we have -1, even though it's there twice, we only list it once. And then we have our x value, our domain of 6. In terms of our range, we have 2, -1, 0, and 4. So in order from smallest to largest, we have -1, 0, 2, and then 4. 3 and 4 are just different ways to represent ordered pairs. So 3, we have a table. So our domain is in our left column, which represents the x's. So that would be 1, 4, and 8. Whereas our range is our second column, or the y's, which we have 1, 4, 1, aka we just write 1 and 4. Number 4, we have, sorry, my dog heard something outside and it startled me too. Number 4, we have what's called a mapping diagram. So our input, our domain, our x, that's all the first column. Okay, x, domain, input. Whereas our second little column here is our output, our range, and our y values. So we just have the values kind of listed in order, and just we have lines drawn, as opposed to putting them with one another in terms of our different pairs within our relations. So our domain for number 4, if I go smallest to largest, we'll list 1, 2, 5, 6. That is a funky looking 6. And then for our range, we have -4, -1, and 0. In number 5, we've got the age and length of 5 alligators, so it's somewhat a real-life situation. We've got a horizontal XY table. So part A asks us to represent the relationship between age and length using ordered pairs. So basically, Because X is the top and Y is the bottom, our ordered pairs are kind of arranged vertically here. So we have the ordered pair 2, 32, followed by 4, 59, followed by 5, 65, followed by 5, 69, and last but not least, 7, 96. Which means then that our domain is our X values, which is listed across the top, or the X coordinate of these ordered pairs. So we've got 2, 4, 5, and 7. Whereas our range is the Y values, 32, 59, 65, 69, and 96. Now, more specifically, we have functions, and a function is a very special type of relation, okay, in which all of the ordered pairs have different first coordinates. And the way I typically talk about it, for every X, there's exactly one Y. Okay, so every X has exactly one Y. So we can't have any duplicate X's. And visually, if we're looking at a graph, the vertical line test will help us to determine whether or not we have a function. So if a vertical line ever intersects a graph at more than one point, then it means that we do not have a function. Our relation is not a function. So if I look at number 1, we're basically looking at this graphically. Are these relations just relations, or are they also functions? So we're looking to do our vertical line test. So we want to draw basically vertical lines everywhere where I have ordered pairs. And as long as I never hit more than one point, I'm in good shape. Okay, so in number 1, I never hit more than one point. So this is a function. Every X has exactly one Y. In number 2, if I look at my vertical line test and I start drawing vertical lines through my ordered pairs, don't want to hit more than one. Well, that last vertical line, I hit 2 ordered pairs. So you'll notice our X value of 3 goes to 2 different Y values. So this is not a function, it is only a relation. So it's a relation only. X value. Little tidbit of information here. It's garbage night. So my little puppy Tipsy is hearing people taking the garbage out. That's why she's going nuts. All right, so this is only a relation because the X value of 3 has more than one Y value. Okay, in number 3, we've got A, B, C, D. Let's look at some vertical lines. Well, if I think about drawing vertical lines in A, I'm never going to hit more than one point, which is good. So that means A is a function. However, B, okay, pretty much any vertical line that I draw, I'm going to be hitting more than one point. So B is a relation only, not a function. C, these vertical lines, they're not the best vertical lines I've ever drawn in my life, but those vertical lines are hitting more than one point, so that is also a relation only. therefore not a function. And you probably are thinking the same thing about D. Any vertical line that we draw, we're hitting more than 1 point. We're hitting 2 points every time here. So this is also only a relation. Okay, so visually it's pretty easy to see. Now, if we're looking at ordered pairs, it might be a little bit more difficult, but take a look at this particular graph in number 2 and how ordered pairs were listed. Notice the x was duplicated. So the x value of 3 had 2 different y values. So we're going to be looking for x values that are duplicated to therefore state that we do not have a function. So if we take a look at our next examples, it says to give the domain and range and state whether it's a relation or function. So our domain, or our x values in number 1, we've got 3, 4, and 5 if we're going in order. And then our range, again going in order, would be -2, -1, 0, and 1. Now, if we want to determine whether it's a function or not, are there any x's that are repeated? Do any x's go to more than one y value? Well, right here, our x value of 3 is going to 2 different y values. So that means this is not a function, it's a relation only. Okay, so relation only, aka not a function, because x value of 3 has 2 y values. What about our next example? Well, if we talk about our domain, if we go in order, we've got -6, -4, 1, and then 8. And in terms of our range or our y values, we've got 1, we have 2 2s, and we've got a 9, so 1, 2, and 9. And it's important to keep in mind that in terms of a function, it means every x must have one y. We don't care about what's happening with the y's. Those y's can be duplicated left and right. Doesn't matter. But every x must have exactly one y. So x of 8 is only listed once. X of -4 only listed once. -6 only listed once. 1 only listed once. So we don't have any duplicated x's. So this is a function, okay, which technically means it's a relation, but more specifically a function. Just kind of like all squares are rectangles, but not all rectangles are squares. So all functions are relations, but not all relations are functions. If that makes any sense. You might need to pause the video and think about that for a second. Okay, so function. So a function is a more specific type of relation where every x has exactly one y. All right, we're continuing with domain, range, and is it a relation or is it more specifically a function as well? So number 3, our domain is our x's happening on the left-hand side, which is our input. So putting the numbers in order, we've got -8, -4, +4, and +5. For our range, we just have 1 and 2 in the y side. So what does that mean in terms of, is it a function? Does every x have one y? Well, how many lines are coming out of each of our y values? There's only one line coming out of each of them. So that means this is a function. Every x has one y. What about number 4? Domain is our left-hand column. It's our x's. So we've got 5, 10, and 15. Our range is our right-hand column, 2, 4, 6, and 8. Now, if we're thinking about relations versus functions, every relationship with x's and y's is going to be a relation, but more specifically is a function. Is it a function? Does every x have exactly one y? Well, 15 goes to one y value of 8. 10 goes to one y value of 6. 5 goes to 2 different y values, 2 and 4. So because of 5, it's not a function. It's a relation only. Oops. Pen is starting to wear out, it seems. So it's a relation only. X value 5 has 2 y values. Okay, so we've seen throughout this domain and range type of experience so far that we can express our relations and potentially functions as ordered pairs, mapping diagrams, which we have here in 3 and 4, and we dealt with a little bit early on, in addition to graphs and tables. So let's take a look at these ordered pairs and satisfy the mapping diagram, the graph, and the table. So in terms of the mapping diagram, the x goes in the first column. So our x values are 1, 2, and 3. They're already in order, so that's nice. The y values are 3, 4, and 5. They're also already in order, so that's nice. And in general, you're just going to automatically put them in order from smallest to largest when you have control. And then you're going to draw lines to make up your ordered pairs. Now, it just so happens that each of these lines are just going straight across because we have the ordered pair 1, 3, 2 goes with 4, and 3 goes with 5. It doesn't always happen, but in this particular case, it did. Next, if we're talking about our graphs, the ordered pair 1, 3, x is 1, y is 3. Next, 2, 4, x is 2, y is 4. And 3, 5, x is 3, y is 5. Okay, so there are our 3 ordered pairs graphed on the coordinate plane. And then in terms of a table, we list, generally speaking, our x values in order from smallest to largest with then their associated y's. And our ordered pairs will go in the table exactly as is because the x value of 1 comes before, the x value of 2, which comes before the x value of 3. Okay, so they kind of drive the train and determine the order. And the x value of 1 goes with 3. The x value of 2 goes with a y value of 4. And the x value of 3 goes with a y value of 5. So all of the situations that we've dealt with so far have been discrete situations, meaning we have distinct ordered pairs that are disconnected if we're talking about these different relationships, okay, other than these couple relations listed in this particular example. These were continuous. They were connected situations. Now, if I'm going to talk about domain and range in terms of interval notation, okay, and we're not just talking individual x and y values like an xy table, we need to make our domain and range be represented with our intervals, more or less using our open parentheses and closed brackets. Okay, so keeping in mind that the open parentheses, okay, normal parentheses, occur with just less thans and greater thans, and the closed brackets are the or equal to pieces. So I typically like to make a little picture frame when I'm trying to determine my domain and my range. Okay, so my domain is my x values. That's my left to right. My range is my y values, our bottom to top. And we always go small to big, so that means left to right for x's and bottom to top for y's. So if I'm talking about my domain, using my interval notation, my farthest left x value is -1. It is included because it's part of the continuous line. It's not an open circle. The far right of our x values is 3. It is also included because it is part of our line. So our domain includes all x values from -1 to +3. Okay, and every x value in between is included. Now, in terms of our range, our y value, small to big, therefore bottom to top, our lowest y value is 2, and it is included because it is part of a line. And it goes up to the highest y value of 5. You would not include something if it had an open circle, which we do not have in any of these particular problems. Okay, so let's talk domain and range in the next one. Let's draw a picture frame. Right along the edges. Left to right, bottom to top. So for our domain, our farthest left x value is -2. It is included. And our farthest right x value is +4, part of the actual line, therefore it's included as well. The range bottom to top, y value of 2 up to a y value of 4, both of which again are included because they're part of the line. Okay, so we'll make note, domain is left to right, and range is bottom to top. Taking a look at number 3, this one's kind of funky, but we can still do it. Left to right. Here's our farthest left. Here's our farthest right. Our bottom is down here. Our top is up here at 6. Okay, therefore, domain in our interval notation, left to right, goes from an x of -2 to an x of +4. Both are on the line, so they are included. And our range from bottom to top, bottom y is 1, top y is 6. On the lines, therefore included. Oops, there's my pen again. And number 4 is very similar to number 3 in the overall shape, left to right. And then bottom to top. So the bottommost bottom and the topmost top. So our domain, our x's from left to right, which It's our blue values. We go from -2 to +3, both of which included because they are part of the line. And the range, bottom to top, we go from a y of 0 to a y of 5. Again, both included. All right, as we gradually wrap up here, we want to evaluate the function. And what does it mean to evaluate the function? Well, the root word of evaluate is value. So we want to find the value if we're given a certain value for x. So in number 1, we have our function f of x equals 5x minus 4. We want to evaluate f of 3, f of 10, and f of -6. Notice 3 is in the spot where x was in the original function. Therefore, we're going to take 3, plug it in for x. So that means we're doing 5 times 3 and then subtracting 4. So f of 3 is equal to, if we do PEMDAS, we would do 5 times 3 first to get 15, drag down the -4, which then gives us f of 3 equals 11. So what this means is, what is the function value when x is 3? Or what is the y when x is 3? Okay, so this is the x value, and the 11 is technically the y value, okay, which is more higher level, is called the function value. Okay, so y is the same thing as a function value. Next up, we want to find f of 10, so we're going to plug 10 in for x. So we have 5 times 10 minus 4. So f of 10 equals 5 times 10 gives us 50. Drag down the -4, so f of 10 equals 46. So when x is 10, the y value or the function value is 46. And in C, f of -6, we're going to plug in -6 for x. Make sure whenever you plug in negatives, you use parentheses. So we have 5 times -6 minus 4. So f of -6 equals -30 minus 4. So f of -6 equals -34. So when x is -6, our function value or y value is -34. Because remember from Algebra 1, f of x is just another fancy way of saying y. Then we have g of x down here, number 2, is equal to x squared plus 3x minus 2. So we're going to do the same exact thing. We want to find g of 2. Take 2, plug it in for x. So that means we're doing 2 squared plus 3 times 2 minus 2. Following PEMDAS, g of 2 equals 4 plus 6 minus 2. Because we do our exponents and then we do our multiplication. And then our next steps are just addition and subtraction. So g of 2 is equivalent to 4 plus 6 is 10 minus 2 is 8. So when x is 2, y is 8. G of 5, plug in 5 for x. So we have 5 squared plus 3 times 5 minus 2, giving us g of 5 equals, following PEMDAS, our exponents come first in this particular case, so we're going to have 25. Next up would be our multiplication, so we can do that 3 times 5 to give us 15, drag down the minus 2. Therefore, g of 5 is equal to 25 plus 15 is 40, minus 2 gives us 38 as our function value when x is 5. And again, when plugging in negatives, we have to be super careful, particularly when exponents are involved. So we're plugging in -1 for x. So we've got -1 being squared plus 3 times -1 minus 2. Notice the use of parentheses. Every time I plug in a negative number, I'm going to use parentheses. PEMDASing g of -1 equals -1 squared is +1. Positive 3 times -1 gives us a -3. Drag down our -2. So g of -1 gives us 1 minus 3 is -2. -2 minus 2 is -4. Okay, and feel free to use your calculators. It is fair game. Okay, so evaluating functions, I call it plug and chug. Take the values for x, plug it in, and evaluate using PEMDAS. And here's just a little introduction to parent functions. It's not a huge deal at the moment. We've got constant functions, linear functions, quadratic functions, and cubic functions, in addition to our square root functions. So a constant function means y equals some constant number, and that's always going to be a horizontal line, where the domain is technically all real numbers and the range is only one particular y value. Then we have our linear function, where we have a certain y-intercept and a certain amount of slope, where the slope is not 0, or technically undefined, I guess, in this particular instance. So in this case, the domain is all real numbers and the range is all real numbers because it's going to rise and run somehow, some direction forever. A quadratic function is a f of x, or y equals x squared. Okay, so an x squared function is going to make a u, okay, where any x's work, but the y's have a minimum point. Okay, so in this particular case for our parent function, y is greater than or equal to 0. For a cubic function, f of x equals x to the third, looks a little bit like a snake. So it goes down and left forever and up and right forever. So that means the domain is all real numbers and the range is all real numbers. We're not going to deal much with that. That'll be more pre-calculus. And then our square root function, well, we've got some issues with square roots in that we can't take the square root of a negative number. Therefore, that's going to impact our domain and range. So you'll see our graph kind of starts at the x value of 0, the y value of 0, and then it goes up and out forever. That is indicative of a domain where x is greater than or equal to 0 and y is greater than or equal to 0. But in terms of what you're going to see and experience in this course, you're going to be dealing with linear and quadratic functions, and you may potentially see horizontal functions or constant functions, and then vertical lines, which technically are not functions because they failed the vertical line test. Okay, so these are going to be our primary focus. The newest one right here being the quadratic function. That's going to be a big topic in Algebra 2.